Previous point. So now we are discussing about multiple linear regression concept. So in the previous video we have discussed only linear regression, simple linear regression. So with a single one independent variable. Now we are going to discussing about multiple independent variables are there. How to solve that problem. So for multiple linear regression example, the equation can be y equal to a naught plus a1 x1 plus a2 x2, and if you have more number of independent variables a3 x3 and epsilon, that is the error value. So now in this example we took two independent variables and one dependent variable, so that we'll see. So now we are going to predicting the score of a student based on the number of hours he studied and number of assignments completed. So for example, in this case x1 and x2. X1 is a number of hours studied. 1 hour student studied and two assignments completed, the score can be 50. 2 hours studied and three assignments completed, score will 60. 3 hours studied and four assignments completed, then the score will be 70. Likewise, this is the data set and we need to create the model, and we need to develop the model multiple linear regression model, and we need to test that model with a unseen data, right? So let us go with an example, this example, and I will see the how to solve this problem. So we can also write that equation in another way, y equal to, by using the matrix method here. So in the previous method we calculated the intercept and slope uh, one way, and this is the another way to calculate the intercept and slope to get the linear regression equation. Right here, y equal to x into b plus epsilon, this is the error term. So here we can see x is a matrix of independent variables. So whatever the independent variables are there here, x1 and x2. So first of all we need to convert these independent variables into matrix, and additionally we are going to adding ones column in the in x matrix. So here this was once, all ones indicating the bias. So you can see here this matrix will be generating from the data set 1 2 1, this is the common column, and 1 2 2 3 3 4 4 5 5 6. So this is the x value and nothing but matrix of the independent variables. And now the target variable matrix is y value. Right now the two matrices are available. The formula is how to calculate the quotients. To calculate the quotient, the formula is x transpose into x whole power whole inverse, and multiplied with x transpose into y. Right, first of all in the first step we need to calculate the transpose of the x matrix. So the transpose of x matrix becomes like it is a 5 by 3 matrix actually. So now the transpose is becomes a 3 by 5 matrix. So after that we need to multiply the transpose matrix into x value. So x value already available with us. After multiplying these two, then we'll get the generated matrix is export transpose into x is equal to 5 15 20 15 55 70. This is the matrix. It will come if you multiply the two values, two matrix. After that we need to perform the inverse value. The inverse value of this matrix we have to identify. Right. So after calculating the inverse, this is the result 0.083 approximately. So we have taken up to 3 decimal values only. So now g minus 0.025, 0 minus 0.025, 0.025 minus 0.005, 0 and 0.05 minus 0.016. After calculating this, we need to multiply x transpose into y. So that is the x transpose is available here, and y matrix already there in the beginning. So we can uh, calculate. After calculating that, we need to substitute these all values into the formula. So to get the quotient values, x transpose. So finally we'll get this after performing these all matrices. All matrices are available multiplications. We will get the coefficients like this. Then 40 10 10. So this is the a naught uh, intercept value, and or you can call it as a naught a1, and this is the quotient of the independent variable 1, and a2 is the independent quotient of the independent variable 2. So you can see here, this is the equation: a0 plus a1 into x1 plus a2 into x2. So in this example we took two independent variables. If it is the three independent variables, we will get here so another quotients, so we can add that term also. So finally the equation is y equal to 40 plus 10 into x1 plus 10 into x2. So this is the result from the data set. So now we are going to testing that model with a unseen data set, that is a new data set which is not there in the data set, which is not available in the table. We can see here. So if a 3 hours studied and 4 assignments completed, what is the score? So our model need to calculate that value. Score is equal to a0 plus a1 into x1 plus a2 into x2. So 40 plus a0 a1 is a 10 into x1. Now x1, this is the x1 and this is x2. 10 into 3 plus 10 into 40. Okay, 10 into 4, by mistake it is written 10 into 4. Now it becomes 40 plus 30 plus 40, it becomes the 110. So this is the calculation of solved example of multiple linear regression concept. Thank you all for watching.